In this video, we're going to learn how to predict the products of decomposition reactions. Decomposition reactions are basically just the opposite of synthesis reactions. Decomposition means to break. So you take one thing and it makes many things because you break the bonds between them. So for example, here we have magnesium oxide. We put an arrow. So usually you know you're doing decomposition when you have only one thing and an arrow right after. Sometimes you might see heat written on top because you might break it down with some heat or electricity. Sometimes you see nothing written on top at all, and that's okay. Just one thing, arrow. And to break it apart, all you do is you write the metal in this case and then the O2 plus the O2. And O2 because that's Hofbrinkel. Just don't forget that. So one type of decomposition reaction is when a metal oxide breaks down, it becomes a metal and then plus O2. So usually, here's an example here. We have lithium oxide. We'll put an arrow there. We might put heat on top, so arrow heat. So it's going to break down to form the metal, and the metal is going to be in its solid state typically, plus the O2 gas, just like that. So you can try out the one just below there. You can pause the video, then check your work. So we'd have a calcium oxide, decomposing here. We'd have our calcium like this, solid, plus the O2 gas. Now, keep in mind, these have not been balanced yet. So if you had to balance them, you could do that afterwards. We could put a 2 over here, or actually a 2 over here. Let's do that. Put our arrow back there. So that gives 4 lithiums, 2 oxygens, and we're good. We're balanced. Here, we just need a 2 here, and 1 there. Now we're balanced. So that was simply decomposing a metal oxide into metal and oxygen. If you can recognize that pattern, nice and straightforward. Sometimes you might see a non-metal oxide break down. When a non-metal oxide decomposes, it becomes a non-metal and oxygen instead. So here we have water, and it's decomposing into the oxygen gas, and then the non-metal is made up of, which is H over here. Just make sure you put H2 because it's Hofbrinkel. Only put the 2 when you're dealing with Hofbrinkel, right? When you're dealing with the HOFBRINCL, nothing else. So here we have CO2. We put an arrow. You recognize, okay, that's a non-metal oxide. It breaks down into the non-metal that it's made of plus the O2. The non-metal it's made of is carbon. It's not Hofbrinkel. It does exist as a solid, though, when it breaks apart. And then oxygen, like that. And that would be in its gas state. SO3. So I didn't tell you to memorize this, but now you'll know it. When S is alone, it's like a special case of Hofbrinkel. S actually exists as S8 solid. If you had just put S, that would have been fine. But now you know S is S8. So we'd have S8 solid plus O2 gas. Okay, next, you can, again, pause the video, try it yourself, and see if you're on the right track. Cl2O breaks down to form Cl2, which is a Hofbrinkel gas, plus O2, which is a Hofbrinkel gas. So you're just breaking them apart, writing their elements, and if there's any Hofbrinkel, make sure you put those, and if not, well, don't worry too much about it. Our next case that we can see is an ionic compound breaking down. When an ionic compound breaks down, it becomes a metal and a non-metal. Just be careful for Hofbrinkel. Metals are usually solid if they're written alone. So here we have sodium chloride decomposing. When it does, it becomes the metal, sodium, and then chlorine gas. So if you think you're ready to try the next one, you can. So here I have zinc fluoride. When it decomposes, it becomes zinc, that's the metal, plus fluorine, it's Hofbrinkel, so it's fluorine gas. Aluminum chloride, decomposing. When it breaks down to its metal, aluminum, plus chlorine gas, just like that. Just as a reminder, these have not been balanced, so you could always go back to practice some balancing if you'd like. I'll show you what the balancing should look like. If you want to pause the video, try to balance and come back and check. You should. That's a great strategy to make sure you're on the right track to assess yourself. So here it looks like everything is nice and balanced already. Here it looks like I need to put an 8 over here and a 12 over here and a 1. So it's 8 sulfurs, 24 oxygens, 24 oxygens. Okay. Here it looks like and you need a 2 here, a 2 here, and a 1 here. Okay, next question. Looks like this is already nice and balanced. Here I need 2, 2, and 3. So eventually you become that quick. It's a puzzle. You go back and forth, but you will become that quick at balancing as long as you practice enough. Okay, our last case that you need to sort of memorize for decomposing is when a covalent compound breaks down. It will break down into its 2 nonmetals. The only thing you have to be careful for is if you have any Hofbrinkel around, you have to make sure you write those properly, but otherwise it's the same as before. So here we have PCl3. That breaks down to form P4 gas and Cl2 gas. You just broke it down into its elements. The P4 there, this is another Hofbrinkel I didn't really teach you. When you have phosphorus, it exists as P4, but you won't see that very often. Okay, so HI, that's going to break down to form H2 plus I2. Those are both Hofbrinkels. The H2 is in its gas form. The I2 is in its solid form. HCl breaking down into H2, again, another Hofbrinkel, plus Cl2, gas. And as usual, you can go ahead and try to balance these for extra practice. These ones are nice and easy to practice. So nothing too different. These have all been the same so far. You're just splitting the elements up. If there's Hofbrinkel, you're being careful with that. Otherwise, there's not even crisscross here. It's nice and straightforward. Just like with the synthesis reactions, you don't need to do the ones that are highlighted in green here. All you really have to do is be able to identify that they're decompositions. So for example, if you see an acid and it's broken up into a non-metal oxide and water, you know it's decomposition because one thing made more than one thing, made 2 things, for example. So here we had H2SO4 broke down to form SO3 and H2O. I need you to identify that that's decomposition. If this reaction happened here, it would form CO2 gas plus water. Again, be able to identify you have one thing becomes 2 things. So that's decomposition. Here, similar situation, you have a base. It breaks down to make a metal oxide and water. So for example, calcium hydroxide breaks down to make calcium oxide and water. You need to know its decomposition because one thing makes 2 things. It's broken apart. Here, KOH breaks down to form K2O, solid, plus H2O, liquid. So one thing makes 2 things, decomposition. Here, CaOH2 breaks down to form calcium oxide, solid, plus H2O. Again, just recognize decomposition. If you like the idea of enriching your knowledge and learning a bit more, you can just spot the trend. Basically, all I did is to find the product. One of them has to be water all the time for the base, and then the other one has to be the metal crisscrossed with oxygen. That's it. Nice and straightforward. Another example of a decomposition, a metal carbonate becoming a metal oxide and CO2. Very similar to the previous case, but in this case, it's a metal carbonate rather than metal hydroxide, which is a base. And the compound that has to be made is CO2, not water. And then the other compound is a crisscross between metal and oxygen. So here we have zinc carbonate, breaks down to form zinc oxide and carbon dioxide. Recognize decomposition because one thing makes more than one thing. Here I have calcium carbonate. That makes calcium oxide, crisscross between calcium and oxygen, plus the mandatory product of CO2, gas. Here, the copper 2 carbonate becomes copper 2 oxide, solid, plus CO2, gas. And those green ones, once again, they're simply enrichment. As long as you could identify its decomposition or justify it is one thing makes more than one thing, is broken down into a few parts, then that's all I really care about there for the green ones. And for those of you who want to try them out, please go ahead and try them out. I've included a couple enrichment problems in the homework if you want to try it out yourself. So the practice problems to review some synthesis and decomposition overall can be found over here. There's also a few worksheets that you're encouraged to try out, but always start by doing the problems in the note first and then doing some of the practice problems within the note. Then afterwards, you can go and do some problems in the homework. I don't expect you to do every single question. Really do it until you feel comfortable. So if there's 20 questions, Maybe you just need to do 5 because you already understand the notes so well. And then when you go to the homework, you're just so quick with them and there's no challenges, then you just need to do 5. You need to kind of prioritize and manage your time, and that comes with some practice. In the next video, we're going to take a look at how to predict the products of combustion reactions. And there'll be a video that goes over these practice problems here so you can assess yourself and check your work.